So how y'all doing this morning? Gonna have some fun here? All right, so I've got a PowerPoint, but we'll keep it casual and informal here, but I'll try to get through a few things to tell you about these fascinating little creatures and maybe what we can learn from them. I'll go through this in a bit here on where they live. So, awesome. Thank you very much. And then that's the clicker. Awesome.
Right. It's the advance.
I'll probably mess it up, but that's all right. So what I wanted to tell you a little about today is the honeybees. You know, the honeybees are pretty fascinating little creatures that we have that live amongst us. And what you may not realize is they're actually responsible for about a third of the food that you eat. And that includes about 80% of the fruits that we eat and the vegetables that we eat, and they depend on pollinators. And honeybees are by far the most important pollinators. So there are other pollinators out there, the butterflies, the bats, that kind of stuff, but they couldn't have the quantity of fruit and vegetables that we enjoy without honeybees. They're also the only insect that creates human food, if you think about it. You know, they create honey that we enjoy. They're the only insect that does something like that. And just to put it in context, you know, there was a guy that was smarter than me that estimated that if the honeybee disappeared from the surface of the earth, we'd probably be gone in about 4 years thereafter. That's how critical they are in the food chain that we live off of. That might be, you know, who knows, might be 5 or 6 years, but they're definitely part of the food chain that we enjoy. So a lot of the foods that we enjoy would disappear without the pollination that they provide. We wouldn't have honey, obviously. We wouldn't have any of the tree fruits, the apples, peaches, apricots, plums. You know, we wouldn't have those without pollinators. We wouldn't have tree nuts, things like the almonds, cashews, coconuts. We would not have cauliflower, which some people might think is okay, broccoli, cabbage, all the melons, the watermelon, cantaloupe, all that stuff depends on pollinators. Berries, strawberries, blueberries, blackberries, raspberries, cranberries, all depend on pollination. Coffee and tea, so that might be a problem. No coffee or tea, okay, and no chocolate, all right, or sugar cane. So a lot of problems starting to happen, you know, so you can start to see where that 4-year thing might play out. Not only would we not have the food to eat, we would probably kill each other without those products. We also wouldn't have grapes, therefore wine. We wouldn't have agave to make tequila. So these are all dependent on pollinators, of which honeybees are the cornerstone to that pollination segment to building the basis of our food chain. And then, of course, these are the basics for other parts of our food chain. You know, the meats and everything that live off of some of the other things further down the food chain are predicated and foundation to the types of things that honeybees pollinate. All right? So pretty key part of our food chain. So let's talk about these amazing insects. There are 3 types of honeybees, and we'll talk a little bit more detail about each of these here in just a minute. There's the worker bee, there's the queen bee, and the drone. All right, those are the 3 types of honeybees that you'll see in each hive. So let's talk about each of them independently and what their characteristics are. So the worker bee is strictly female, right? We already knew that, right? All the work is done by the females, right? So they're the largest population of the hive. They are responsible for caring for the young, storing the food, cleaning the hive, foraging for nectar, pollen, and water, protecting the hive, tending to the queen, and regulating the temperature of the hive. All right? They make wax to build the hive. They actually secrete little plates of wax that they can use to build up honeycomb. They live for 5 to 8 weeks in the summer. They live longer during the winter when there's less work to be done. Their metabolism actually slows down, and so they can live longer through the winter, and the queen doesn't have to work as hard laying eggs to keep the colony going through the winter. But during the summer, when there's a lot of things going on, they're out there foraging, collecting pollen and nectar, and making honey, they live for 5 to 8 weeks. The next honeybee, the queen bee, is, there's one. And you can see here, the picture here is a marked queen. That red mark is a code that beekeepers use that tells you how old that queen is. There's 5 colors that they rotate every 5 years. And so if you have a marked queen that you've gotten from a beekeeper, you can tell by the color of that spot how old she is. And then you can get an idea. You might need to replace her with a more productive queen. Queens are strictly female. They're the only fertilized reproducer of the hive. All right? they lay 1,500 to 2,000 eggs per day. All right, that's pretty much all she does is lay eggs, lay eggs, lay eggs, because that's the future of the colony. When you think about all those worker bees that are only living for about a month and a half, well, as they die off, you need to have these new ones being born every day. So in a typical hive, you'll have about 50,000 worker bees, and if those only last for, call it 50 days, that means 1,000 bees a day are dying, and you need to have the eggs being hatched up to replace the colony and actually grow it during the spring and the summer. So her main job is lay eggs. That's the survival of the colony right there. And all the other functions of taking care of the hive are taken care of by the worker bees so that she can lay eggs. So she comes from a special larger cell. The way a queen is created is the worker bees actually decide it's time for a new queen. They collectively decide amongst themselves, we need a new queen. And this will typically happen as the queen gets older and she is less productive and she's not laying enough eggs to stay in the hive. The worker bees will decide, we need a new queen. And the way they do that is they take one of the eggs for what would otherwise be a worker bee, and they have a special hormone called royal jelly that they can feed to that worker bee and make her into a queen. All right? When that queen is born, there will be a fight to the death for which queen continues on. All right, so there's only one queen in each hive. So that's how the queen is replaced. That typically queens will live for 4 to 5 years, but as they get to the edge of that time frame, they'll become less productive, and professional beekeepers or commercial beekeepers will typically go proactively replace the queen at 3 or 4 years. They'll actually go put a new queen in, take the old one out, kind of get rid of her like that, and that's how you keep the hive strong. All right, so the third kind of bee is the drone. The drones are the males. Their only job is to mate with a new queen. That's all they do. It's not a bad gig, except for after mating with the queen, the drone dies. All right? Now, the other thing is, because these drones really don't help take care of the hive like the worker bees do, they are kicked out in the fall. You know, they're just sitting around eating the honey, and the worker bees are saying, hey, we need this honey to get through the winter. That's our winter food supply. And so literally around the date of the first frost, around November, around here, you can go out to the front of the hive, and all the drones are dead that have been evicted from the hive. They've been kicked out, and they've frozen to death overnight. So they're kicked out, but they're only around to fertilize a potentially new queen. Well, how do we get more drones? Well, the next spring, the queen can control when she lays an egg, whether it's a male or a female egg. So now, who decides that? Well, the worker bees decide what kind of egg the queen should lay. And the way they do that is they will, as they're building out their honeycomb, the little 6-sided hexagon honeycomb that they make for the queen to insert an egg into, they'll actually make one that's a little larger to signal to the queen, you need to put a drone egg right here. All right? So it's the worker bees that are deciding how many drones they need to have, when it's time for a new queen, and just all these other things about administering the hive. It's not the queen. The queen is just laying eggs. So you hear all those phrases about being the queen bee. It's really the worker bees that are actually making it all happen. All right? Sorry, let me catch up a little bit here. So a couple of interesting bee facts. So the buzz that you hear with a bee is created by the wings beating at 230 beats per second. That's 10 times faster than a hummingbird. All right? So that's what's creating that buzz that you hear when a bee is flying around. The honeybee can visit up to 1,000 flowers in a day, and they'll go as far as about 5 miles from a hive and just navigate using the sun to get back to their hive. They will communicate with each other using a bee. When they go out and find a good source of pollen or something else, they'll come back and they'll communicate to the other bees where this is. And they do this little waggle dance, kind of like a figure 8, you know, when they're excited, and they can describe the direction and the distance of where the good stuff is. That's also how they describe describe when they want to move to a new home. They go out and they search just like you do when you're looking for a new home. You go out there and you check out a few different places where you might want to live, and you come back and you have a conversation about this one, and by process of elimination, you figure out that's the one we're going to go to. The worker bees are doing all that work and coming back and communicating that through this little bee dance with where the good stuff is. So 1 pound of honey requires about 25,000 flights, covering 55,000 miles to about 2 million flowers. So a lot of work involved with that little jar of honey that you enjoy. A typical colony here in Texas produces about 60 pounds of honey annually. So a lot of bees doing a lot of work, flying a lot of miles, visiting a lot of flowers to create the honey that we enjoy. All right, so a few more bee facts. The hive, inside the hive, it stays at about 95 degrees all year long, even in the winter. And the way they do that is the workers, here again the worker bees, regulating the temperature by either fanning, like in the summer. This is a hive, and we'll get into the details of this later, but there's the entrance for the hive, and the worker bees will line up along the front and flap their wings to ventilate the air in and out of the hive. Likewise, in the winter, they will ball around the queen, and they will do this kind of shivering motion to generate heat to keep the queen alive, because that's the survival of the colony. Without a queen, you don't have a colony. And they'll protect the queen. They'll actually take turns on who's on the outside of that ball, because that's the less desirable place. That's where it's a little cooler. They'll actually rotate who gets to be on the inside and enjoying the same warmth that the queen is enjoying. But anyway, they keep the hive temperature fairly constant all year. So here again, like I was saying, the workers, not the queen, determine how many drones they're going to have, when it's time to replace the queen, where the hive should be, the hive location. Whenever a colony decides that they've outgrown their hive, they don't have enough space, or there's a threat, or maybe it floods from time to time, they'll decide, we've had enough, we're going to move somewhere else. What they do is they swarm. That's when they go and they hang out on a tree branch. And I'm sorry my picture is cut off a little bit, but I actually have that a little later in the presentation. And they'll hang out on a tree branch. And that's when they're the most vulnerable. They're not aggressive there, but what's inside the middle of that cluster of bees is the queen. They're protecting the queen. And in the meantime, some of the worker bees are acting as scouts to go out there and find new places where they might live. Old, rotten trees with a gap. The eaves of houses. A lot of times they end up in gaps in the walls of houses or in attics. And so they're out there checking these things out, and they come back and do the bee dance and describe what they found, and then a few more will go back and check it out until they narrow it down to where they're going to go live. That's a swarm. They're only in this state for usually about 2 days, and then they'll be all gone because they found a new place to go move to. But that's all driven by the worker bees when they decide it's time to leave their colony, leave their hive, and find a new place to live, and then the decision about where they're going to live. They also guard the entry of the hive. Whenever their bees can come along and rob their honey, they will post worker bees along the entrance to guard it and only let the honeybees that belong to that colony into the hive. And so anyway, they do a lot of cool stuff. I'm going to skip that slide for just a minute. We'll come back to that. But this is where I was going to tell you a little bit about how the hive is made. I've got the bee suit here. And this doesn't work so much with a mic, but they have full body bee suits as well, but generally with jeans and this, I can go out there, and gloves, I can go out there and mess with the bees. But the bees really aren't that aggressive. It's only when I'm trying to steal their honey that they're not too happy about that. I probably wouldn't be very happy if somebody took the roof off of my house and tried to take my stuff, so they get a little aggressive at that point. But the way the hive is built, take this here. You have the basic of the brood box. This is where the queen lives. This is where she plants the eggs. This is where they raise all the young. And then each of these frames here, there's 10 frames in this box, and there's room for honeycomb on both sides. And so you can see these ones have already been built out. They've been used. I'll get a new set of bees for these here in a month or so and fill that in. So that's the bottom brood box. And then you have a queen excluder. This is what I put right here. And it has an opening big enough that the worker bees can move up and down, but the queen can't. I want the queen staying right here because I don't want her laying eggs further up, because what I want above is just honey. They can also store pollen and some other things like that. But then you have the smaller box that just fits on top that also has some of these frames that are stuck in right now. There we go, we'll just do that. So it has the frames likewise that have honeycomb on both sides. And as they fill this up, this will hold about 20 pounds of honey. And then as they fill that up, as we go through the summertime, spring and summertime, as that gets filled, I can just add another box and keep adding boxes as it fills up. And then when I go to harvest the honey in around August, I'll pull those off and we'll show you how to extract the honey. And then on top of that, they just have a covering here, and then one with metal to protect them from the rain. And that's, so this is the entrance here. That's the only place they can go in and out. And that's the anatomy of a beehive. The bottom of this one actually has a screen, and that's something that enables it to be better ventilated in the summertime, but I can slide a piece of plywood or plastic there to block that, to protect them in the winter and keep them from getting quite so in the winter time. So let me pull that off because that's a little warm. But let me show you how we start a hive. So you go get a nuke. A nuke, the nucleus of a colony, is a queen and about 100,000 worker bees. So that's to get things started. Let me show you some videos. I have some videos that my son helped me out with, so the movie quality is not top flight, but maybe you can get a rough idea of what this is like. So this is a nuke. It's a box that has 5 of those frames in it. And you open it up and you have a queen and about 10,000 worker bees to get things started. And then, let me go, go through a process of opening up one of the brood boxes here. Here, like I said, it holds 10 frames. The nuke will have 4 or 5, and I'll just put those into the brood box, and then they can start building out the remaining frames with additional honeycomb, places to lay eggs, store pollen, store nectar, and all that kind of stuff. It gets kind of sticky because the bees actually have a compound called propolis that they use to actually water seal the inside of their hive, and they can actually use it to weather it in, but it also makes all this stuff stick together. Like that's why I couldn't pull those out. So you have to have a little pry bar to get some of this stuff. But you pull those frames out, you see honeybees on both sides flying all around. Yes, my son has a suit, so yes. He has a smaller version, yes. But just get them out one frame at a time, get them going kind of gently. As long as you don't jar them, they generally don't get agitated. They're generally pretty calm, but you just get them out and slide them in, keep them from getting bumped around too much. Kind of push them close together like that. And there's the beginning of a new colony. And you can see some of the hives next to that one that are more established, that already have some of the additional honey boxes on top. Generally, you'll do this in late April, early May. That'll be the time to get a new colony going like this. And then you just dump the stragglers in there. So that's how you start a colony. You get a nuke. Now you can get them actually through the mail. You can get a box of bees through the mail, and I've done this a couple of times, and it's kind of funny because I would come home to my answering machine and I have like 4 messages from the post office, and they start out with in the morning, Mr. Coy, we have your bees here. You can come pick them up. And then later in the day, Mr. Coy, we have your bees here. We'd really like for you to come pick them up. And then later in the day, we close at 7 o'clock. You can come get them anytime. So, but they're just in a metal cage. You can see them, but it's in a cage that you can just open up one end and dump them into the hive. I've had a little more success getting them in a nuke, like in a box like this, where I go pick them up. It's a little less traumatic for them than going through the U.S. mail service, but I can only imagine. So that's starting a hive. So let's go a little bit to how is honey made. Sorry. So a worker bee collects nectar from flowers in its honey stomach. They actually have a separate stomach for the nectar than their food stomach. She'll pass it back and forth to other worker bees. They chew on it for about 30 minutes each, and they have an enzyme in their saliva that will actually cause it to become more dense. So they're kind of throwing it up to each other. As it thickens, they put it into a honeycomb cell, and they fan it with their wings to further thicken it, create some additional evaporation until it's at a point where it's about, call it 15 to 18% water content. And then when it's ready, they'll put a wax cap on that cell, and that becomes their storage. This is, after all, their winter food supply. So a teaspoon of honey takes the equivalent of 8 worker bees their entire lives to produce. All right, just to put that in context. So stealing the honey, let me, one more video here. So this is where you go grab those frames out, and you use a hot wax knife to cut the wax caps off. So this is where the bees have put the wax caps on the top to get the honey out. And you just cut that off, and now you're exposing the honey, getting the, opening up every cell. And then you put that frame into a centrifuge, and it'll circle it around, it'll spin all the honey out, and it'll all just flow to the bottom, and then you can strain it and bottle it. The cool thing is, with those frames, now they're kind of sticky and messy. I can just put them back out into the yard. The bees will come clean them up for me. They'll take that remaining honey, take it back into their hive, use it for themselves, and also clean that up, and then I can reuse those frames in the following season. All right? So you basically, there you go, cut it with the hot knife. There you can see a close-up of the cell, where you can see the honeycomb with the cap taken off, and then all the honey kind of bleeding down there. And then when you get it out of the centrifuge, you run it through a couple of layers of cheesecloth. This is the same kind of cheesecloth that you might use to strain paint that you get from Lowe's or Home Depot. And that's just getting the particles of wax out. So you're straining it down. You don't really want to filter it. So what you see, the difference between local honey and what you might find at the store, is that the store, they've heated it up to increase the viscosity of it, and they strain out a lot of the things that are beneficial, things like pollen, and actually a lot of the taste and flavor, if you ask me. But this is where you're just straining away some of those, chunks of wax and stuff like that, so that you get a more pure honey. So this is my honey. It comes out a little darker than a lot of the honeys that are out there. It's strained, but it's still raw and unfiltered, so it still has the pollen. So that's why it's beneficial, if you have allergies, to have local honey, because then you're getting small doses of the local pollens that help your body to build up the immunities. If you get this honey from the supermarket, all that stuff is filtered out. Okay? This is my honey. I sell my honey to the Grapevine Farmers Market just up the road, and it's under the label Lily Bee. Lily is the granddaughter of the lady that runs the place, and she wanted honey named for her daughter, and I was fine with that. Unfortunately, it disappears pretty quickly after I harvest it. I harvest it in August, and it disappears within a couple of weeks thereafter. So just FYI. So, we've heard a lot about the threats to the honeybees. There's a lot of bees dying off, a lot of decreases in the number of colonies that we have out there. And I think there's really kind of 4 main threats that are causing this problem. One is monocultural farming. That's where we have, single crops. We're clear cutting the areas, deforesting the place where there's just one crop in the area. And the problem for bees is that they're basically just living off of one kind of pollen there. It'd be like if you had to eat just one kind of food for weeks on end. And so it's not a balanced diet when we create these farming cultures that have just one crop there. That's not natural for honeybees. The other thing is the landscape redesign. Here again, with the deforestation, we're eliminating a lot of the biodiversity that are critical for the honeybees to have a balanced diet, different kinds of pollen, and they also lose their habitat as we do that. The third thing, and this has become more recent, is the global spread of pesticides and diseases, or parasites and diseases. Obviously, as the world has become a smaller place, it's easy to hop on a plane this afternoon and be on one of 6 other continents tomorrow. The same thing has happened with diseases and pests. And so we have a pest that particularly affects the honeybees called the Varroa destructor. It's a type of mite that just entered the U.S. in 1987 from the Orient, and that has become part of the problem that we actually, as beekeepers, we now have to treat for. And then the last thing that's become a bigger problem is the use of pesticides. Now, obviously, if you use them according to label directions, that's one thing, but a particular class of pesticides, and I'm not even going to try to pronounce that word, but it's in a lot of the high-powered insecticides, and that seems to have, a lot of the data seems to point to that creating a problem with the nervous system of bees. And so by putting those pesticides out there, you're killing off the insects that you don't want, but you're also killing out the insects that you do want. All right, so those are kind of the threats to the honeybees. Well, what do we do about it? Well, part of the problem is that we have a kind of a cycle of finger pointing. You know, we as consumers, we're looking for a lot of food, a lot of cheap food, and we're telling the commercial ag producers, go crank this food out. Well, the most efficient way for them to do that, tell the farmers, I want, you know, monocultural type of environment that produces it extremely efficiently. I don't want a bunch of pests, so you got the farmers being under pressure to use the pest controls, and then you got the regulators that are being influenced from all different sizes, trying to figure out how to balance this all out. And so really, you know, it's an agricultural system that we've created really to create plentiful and cheap food, but it also creates some byproducts of that in that we lose a lot of the biodiversity that bees need and have further incentives to use methods like pesticides to get the maximum yield of the crops. So we're kind of a lot of just finger pointing there. So you think, well, how can I save the honeybees? Well, you could stop eating. That's probably not a good solution. I don't know if I'd recommend that. Probably not. Now you can do, you know, the planting flowers, minimize your insecticides, protect the swarm of bees, you know, become a beekeeper. I have a good, you know, it's a lot of fun. That's all good stuff, you know, but that's really not going to change the overall cycle that we looked at on the prior slide. So you're really kind of like, well, what do I do with that? Well, the honeybees actually have an answer, and that's to think like a honeybee. So remember what I told you. In their lifetime, a honeybee makes about a 1/12 of a teaspoon of honey. So not a whole lot. And think about this. As a colony, they're going to need at least 50 pounds of honey to get through the winter. Well, if you're a honeybee, it's like, holy cow, that is just a daunting task. How do I create the 50 pounds of honey that my colony is going to need to get through the winter? That's their winter food supply, and I can only make this much. Well, does she give up? Obviously, she, remember, the boys don't do any of the work. Does she give up? No, she gets to work. So here again, the way she does it is she and her sisters will make 2 times to 3 times the amount of honey that they need for the winter. They'll go out there and during the spring and the summer make about 100 pounds of honey. So that not only is there enough honey there for them to get through the winter, but there's enough that I can take some. All right? So the cool thing is that she does it for her sisters that really haven't even been born yet and that she'll never meet. She'll be dead by the time those honeybees that'll get the colony through the winter are going to be taking advantage of the honey that she's creating. So really it's just a matter of figuring out what's that little thing that you can do that makes part of a bigger picture, that makes a difference on a bigger scale. So how can you save the honeybee? Well, like I said, there's definitely some things that you can do to help, and it's actually kind of fun along the way. But you know, things like growing your own food, like a lot of you guys do, creating some biodiversity, even in our own little environment, it's not going to change the overall agricultural infrastructure of the country, but it's all these little things that we can do along the way. You know, you share your extra, just like the honeybee does. The honeybee shares honey with us. Well, not by choice, but anyway. But you know, take a long-term view to making the difference. Make the difference for people that you don't even know yet, that you haven't met yet, and that in a lot of cases haven't even been born yet. Well, so how do you solve something so big? So honeybees have an answer for this too. So remember the swarm. This is the picture that cut off earlier. So you have the swarm of bees that is, you know, with the queen in the middle. They're looking for a new home. They've left their old home. They're hanging out on a tree branch somewhere for a day or two while they figure out where they're going to go live next. Well, they're masters of mass movements. So remember, you know, this is all the worker bees just collectively deciding that this is what they need to do as a hive. This isn't one person. This isn't the queen telling them, this is what you need to do. This is them deciding collectively, this is in the best interest of the overall colony. So they come back and they waggle. So think about what are some of the things that make you waggle? What makes you excited? What are you passionate about? And just go make a difference with that little. Make sure that your 1/12 of a teaspoon of a honey counts. And that's all I have. Have a honey day. So.